so we're back again with another video. Today we'll be talking about CRISPR gene editing, and how it can allows us to rewrite human biology, and completely wipe out hereditary diseases entirely, along with other benefits of completely fixing world hunger and everything through this gene editing. It really is some spectacular software that we will dig into deeply now. 3, 2, 1, go. CRISPR works by creating a double-strand helix break, literally cutting your DNA in half. For a while, we thought that it would just kind of cleanly repair the break in the DNA. We were wrong, okay. When DNA chops, it triggers a volatile cellular panic. Mobile genetic energy elements, specifically one called line 1, exploit this break, and then they replicate to forcefully fill themselves into the wound. The problem with this is that in 5 to 6% of experimental runs in human cells, this causes massive cell damage, and if the cell's natural tumor defense mechanism is weak, it could, even a single mistake could trigger cancer, which is not good. And when you're editing millions of stem cells, with a 5% chance of them failing, you're doomed, you're cooked. 5% of millions is still hundreds of thousands, or tens of thousands. So, you're gonna get cancer. 2, 1.
Fortunately, molecular biology moves fast. Scientists have already built 3 upgrades that don't rely on cutting DNA. Number 1, base editing. Instead of cutting, it uses deactivated Cas9 to chemically convert a single letter, like C or T. This drops cancer risk from 5% to less than 0.01. Let's go! Number 2, prime editing. It acts like a word processor, allowing targeted insertions and detections without double-stranded breaks. It can fix up to 89% of known genetic defects. With RNA editing, it leaves your DNA completely untouched. And edits transcendent mRNA instead, because RNA degrades naturally. Any mistakes are entirely reversible.
Okay, ready? 3, 2, 1, go.
If these blend of high stakes engineering and unpredictable biology sounds like science fiction, that's because it is. It's exact narrative engine for Andy Weir's Project Hail Mary. In an offer humanity faces extinction to prevent a microbe called astrophage stimming the sun by 10% and to start a leader with absolute global authority to save the species. She strips away the individual rights and kidnaps Rayland and forces him into a suicide mission. It's exact same logic used by biohackers who argue the potential cure for diseases justifies bypassing international laws and human consent. But the universe doesn't always care about our parents. In the book, Grace selectively breeds the nitrogen resistant predetermined agent called Tau 82.5 to solve this crisis. But under that intense evolutionary pressure, the microbe also mutates to be able to pass through xenonite, a material thought to be completely impenetrable. This fictional escape purposefully mirrors available thing called called retrotransmission, which we apply carefully genetic threshold instead of using sick classical CRISPR. The biological system finds a chaotic, unpredictable way to survive. Nature refuses to be cleanly contained, unlike me.
And 2, 1, go. Without their consent, and all forms of non-medicinal, cosmic, or cognitive enhancements must face an absolute international prohibition. We don't like people editing themselves. It's bad, because only rich people can do it. Yeah. Backed by unidentified crime policies and immediate freeze of all international research funding, this door must remain permanently locked in the Constitution. It must be one of the laws that can't be changed. You know what I'm talking about. Yeah. Until molecular chaos of that word is completely and a transparent global moral conscience is reached. Humanity cannot risk playing roulette with its own genetic lineage.
Point 2 of how it reflects to the book. This fictional journey perfectly reflects the real-world path of CRISPR co-inventor Dr. Jennifer Doudna. She began her career focused entirely on isolated basic bacterial biochemistry. But at that point, she realized CRISPR's monumental power to alter global ecosystems and human lineages. She stepped out of her quiet lab and into the spotlight. She actively organized global and took the stage at international summits to demand strict ethical stewardship. Both Grace and modern geneticists prove that a scientist cannot retain detached from the civil consequences of their creations. Oh yeah. And
Science doesn't just exist in a vacuum. How we view CRISPR gene editing and everything related to it depends on who's telling the story. The author makes up a lot of the way we look at the miracles and nightmares of CRISPR gene editing. But by looking behind the headlines and everything, we can look at what the author actually meant. First, let's look at the academic biothesis treatise, co-authored by prominent biothesist Dr. Othel Chaplin. In Embo Reports, writing for an audience of academic peers and global polymakers, his primary purpose is to sound the alarm on regular. Science doesn't exist in a vacuum. How we view CRISPR gene editing and science overall is heavily influenced by the authors of the information we're reading about. Let's take a deeper, in-depth look into what the authors mean in the articles and the possible biases they may have. First, let's look at the academic bioaesthetics treatise, co-authored by prominent biothesis Dr. Arthur Chaplin. In Embo Reports, waiting for an audience of academic peers and global polymakers, his primary purpose is to sound the alarm on the regulatory lag chasing. This fast-moving technology. Chaplin's tone is strictly objective, analytical, and heavily cautionary. He frames some massive benefits of Castle as strictly significant, but also completely conditional on strict oversight and strict international oversight instead of relying on sensationalist design wavy clickbait. His narrative focuses on macro-level systematic hazards, warning that the sheer affordability and rapid democratization of CRISPR would allow rogue actors to run roughshod over long-standing biosafety protocols, ultimately destroying public trust in science. He's a Republican. Keep that in mind. But if you step out of the ethics board and into an active laboratory, the perspective shifts completely. In her clinical research report for Boston Children's Hospital, science writer Nancy Feisler targets a very different audience. Like that word. Medicine researchers and advanced healthcare consumers. The purpose is to disseminate critical empirical laboratory data regarding how cells react to being edited. Feisler's tone is precise, scientific, and strictly data-driven. She frames classical CRISPR as a literal double-edged sword, while she anchors the benefits of gene editing in active clinic trials for blood and metabolic disorders. She uses cold numbers to quantify micro-level risks, exposing a harrowing 5 to 6% word count. CRISPR triggers volatile jumping genes that would cause large-scale chromonesia. That word, I talked about that earlier. We don't need to talk about it again. The contrast between these two sources highlights the fundamental split between the scientific community. Chaplin takes a wide lens philosophical approach, one about the wide-scale social community, while Feisler takes a more tight lens, focusing on a molecular approach and heavy cellular mechanics, and using raw data not to slow us down. So, next generation base and prime editing as the only biochemically safe path forward to truly understand the sovereignty of genome. We might both be balancing the structural caution of the enthusiasts with the empirical solutions of the lab.
Done?